Yay! Okay, so we today are looking at multiplying and simplifying radicals, and they were all just informed that this is our normal math show, that this is notes for both regular and accelerated algebra 2. The response was, whoa.
Wow.
There we go. Are we that smart? Yes. Yes, you are all that smart. Okay, here we go. All right. Yesterday the question was asked, what do we do if we don't have a perfect square root? And I think that was in this class. And I said, okay, well, that's coming up soon. So here we are. You all can tell me, I hope, the square root of 36 is what? 6. Good. It has a perfect square root, so once you take the square root sign is no longer there because you took the square root, right? Is there a perfect square root of 32? No. What that means for us is that we're still going to have a radical of some kind of square root sign in our answer when we simplify this. The goal with simplifying radicals is that you want to get all of the perfect square roots out of the square root sign, okay? So what does that mean exactly? Can anybody think of two numbers that you can multiply together to get 32, one of which is also a perfect square? Two numbers that you can multiply together to get 32, one of which is also a perfect square. Olivia? 4 and 8. Give it up for Olivia. All right. So I just rewrote that as the square root of 4 times the square root of 8. Because like Olivia just said, 4 times 8 is 32. Now you guys tell me, what is the square root of 4? 2. So now we're down to 2 root 8. We got one of the square roots out of there. Okay, so I'm seeing some frowns and people being confused. Are there questions? Now's a good time to ask if you have them. Okay, people should not be throwing things. Okay. Questions? Okay, remember I said we want to get all of the perfect squares out from under the radical. Everybody look at what's under the radical now. We have an 8 left over. Anyone see, are there two numbers that we can multiply together to get 8, one of which is also a perfect square? Samantha? 4 and 2. Everybody give it up for Samantha. Okay. Everybody again, what is the square root of 4? 2. And, so that's what we have so far. What's 2 times 2? 4. So it's 4 root 2. All right, questions on that? Okay, I'm going to show you guys one other way of doing this. If you are really good at your times tables and can identify perfect squares, this is a really good way for you. You may have started out this one saying the square root of 32 is the square root of 16 times the square root of 2. That was another way. 16 times 2 is 32. What's the square root of 16? 4. So 4 root 2 again. Okay, so the larger perfect squares you can find, the quicker you're going to get to your answer. If you are not feeling the whole times table thing and you're not really that big a fan of math, you might want to try this next approach. Okay, ears perked up. Okay, here we go. So we're going to start the same way. Somebody give me two numbers that I can multiply. It doesn't matter if they're perfect squares or not. Two numbers that I can multiply together to get 32. Aiden.
16 and 2.
Okay, good. 16 and 2. Everybody give it up for Aiden. Okay, we want to keep breaking down the numbers until we have only prime numbers left. Does anybody remember what prime numbers are?
Those things that are on the end of the tree.
They're on the end of the tree. They're firsts. What does all of that mean? I tell you, I know exactly what you mean, but for those of us who don't have any idea what you're talking about, somebody explain it. Lorenzo?
It can only be multiplied by 1. Like, hold on.
Okay, good. So let's...
To get to that number, they could only be multiplied by 1 of themselves.
Perfect. Everybody give it up for Lorenzo. Let me see what he said a little louder. He said the only way that we can get a prime number by multiplication is to multiply 1 by the number itself. Okay, so we can only get 2 by multiplying 1 times 2. Or the number 7. The only two numbers we can multiply together to get 7 are 1 and 7. Okay? Now, 16 breaks up into what and what? Everybody shout it out. 2 and 8, that's 1. Okay, what about 8? 8 breaks down to 2 and 4 breaks down to 2 and 2. Okay, what we're going to do with all of these prime numbers left is we're going to put them in numerical order back underneath the radical sign. Numerical order meaning smallest to greatest, except that we only have a 2 left. So we have 5 2s. 1, 2, 3, 4, 5. Put them back out underneath the radical sign. And what you guys want to do, since we're looking to find the square root of this, you're looking for pairs of numbers. Okay, so we have a pair of 2s here, a pair of 2s here, and that guy's left over. So we leave him alone. Okay. So within each pair of numbers, one gets canceled out, the other one comes outside. One gets canceled out, the other one comes outside. And then anything that does not have a pair stays underneath the radical. Okay, so 2 times 2 is 4, so it's 4 root 2. Okay, so you now have seen 3 different ways of getting the same answer. I want you guys to pick one and stick with it. Or, some of these approaches might work better in certain scenarios and other in other scenarios. So you guys just do what you need to do. Are there questions on any of these? Because we're really just getting practice with this today. Cool, let's do another one. The square root of 300. Somebody start me out in whichever approach you prefer better. Tyler.
100.
103. Everybody give it up for Tyler. Okay. This 100 or 3, do either of those have a perfect square root?
100.
Square root of 100, Alyssa, is? 10. Everybody give it up for Alyssa. And then we're done. Questions on that? You also could have done the tree. Do you guys want to see the tree on this?
No, thank you.
No. Okay. How do you really feel? Okay, here we go. Now, what if we have something like the cubic root of 80? Okay, we've been dealing with square roots so far, and we were looking for perfect squares. Now that we have a cubic root and we want to simplify it, anybody have any idea what kind of numbers we're looking for now? Perfect cubes. Good. Okay, so I'll say this. For the way that I do these, only because I've been doing this as long as I have, I can easily look at that and see what a perfect cube is that is a multiple of 80. However, I also would say that a factor tree works really well for anything that goes beyond square roots. So let's try that on this one. Square root of 80 is what? Oh, okay, wait, sorry. Okay. 80 you can get by multiplying what times what? Alyssa. 8 and 10. Give it up for Alyssa. All right, somebody break up 8 for me. Sloan. 2 and 4. And 4 is what and what? 2 and 2. Give it up for Sloan. Okay, now 10. 10 breaks up into Aiden. 5 and 2. Everybody give it up for Aiden. Aiden gives it up for himself. Okay. So now we're going to put these again in numerical order underneath the radical sign. So we have 4 2s and 1 5. Now, we circled pairs of numbers in the last example because we had a square root. How many do you think we're looking for now? What? 3 triples, because we are looking for a cubic root. So we have a triple of what here? 2s. So we circle 3 2s. It's at 3 because it says that right here. Within each triplet, 2 get canceled out and 1 comes outside of the radical. I'm going to show you the other way on this too. But so it's 2 cubic root of 2 and 5 both stay underneath. And what is 2 times 5 again?
10.
Okay? Questions on that? Yeah, Aiden.
So, you know how you cancel out 2 of the 3?
Correct.
Is it always going to be 2 that you cancel out? Say if there was like 4?
So if there are 4, you're canceling 3 out. Basically, you always only want to bring out one of whatever the number is that you have circled. And everything else gets canceled out. Other questions? Now, really quickly, for those of us who prefer the other method, the cubic root of 80 is the same thing as the cubic root of 8 times the cubic root of 10. 10, not 8 again. What's the cubic root of 8? 2. 2 times 2 times 2 is 8. So we end up getting 2 cubic root of 10 again. All right? Either way works. Next, the square root of 12ab cubed c squared. All right. So here we go. Let's break this up first And we're going to separate all of the different things in this problem. Meaning, we're going to put the 12 under its own radical so we can look at that by itself. We're going to put the a under its own radical so we can look at the a by itself. Same thing with the b's and the c's. All right, and then we're going to take them one by one. 12. Can anybody think of two numbers we can multiply together to get 12, one of which is a perfect cube? Lorenzo. 4 and 3. Good. We're going to give it up for Lorenzo. Yay. Okay. Now, how about A? We're going to take these one by one. Is there anything that we're able to do with the A? No. Why not?
Because A is booty. Sorry.
Because A is booty. Sloan, you're great. Okay. We can't do anything with that because why? Aiden? Because it's a what? It's a letter. Okay. Zach? It's by itself. Okay, good. It's by itself. We can't, there's no perfect square root of A. Good. Everybody give it up for Zach. Okay. B cubed. Is there any way that we can break up B cubed so that it is B times B to some power, one of which is a perfect square? Cole? I can't hear you. Excellent. Everybody give it up for Cole. He said B times B squared. How many people agree? Clap if you agree that B times B squared is B cubed. Good. Okay. And then the last one, square root of C squared. Just C, right? We all learned yesterday that squared and square root cancel each other out. So we'll put that C on the end. All right, now we want to go through and actually take any square roots that we have, and then we're almost done. Okay, so everybody, what's the square root of 4? 2. There is no square root of 3. We're going to leave that alone. There is no square root of A. We're going to leave that alone. There is no square root of B. We're going to leave that alone. What is the square root of B squared? B, so they cancel each other out. So we have a B, and we have that C from before. The only last thing you have to do is multiply everything outside of the radicals together and everything underneath the radicals together. So if I do the underneath first, I have 3 radicals left. I'm literally going to combine them underneath one that says 3AB. So can anybody tell me what they think is on the outside of the radical? Sloan? 2BC. Good, 2BC. Everybody give it up for Sloan. Whoop. Dimming, dimming. All right, how are we doing on questions? We are all A-okay. Okay. Oh, spoke too soon. We only have one more example after this. Okay, so here we go. Somebody tell me, we did a lot of factoring last semester, which I know you all loved. So, 3x squared plus 12x plus 12. Aiden? Cool, everybody give it up for Aiden. So, he said factor out the 3. Aiden, what are we left with underneath or in the parentheses once we factor that 3 out? Good? Yeah, that's right. Cool. Okay, now, can we factor x squared plus 4x plus 4? Yes, true. How do we do it? Let's see. Alyssa. Okay, you can use the diamond if you want. Excellent. And if you do that, 2 numbers that multiply to 4 and add up to 4 at the same time are what and what? X plus 2, x plus 2, which would you agree is x plus 2 squared? Cool. Everybody give it up for Alyssa. Aiden, were you going to say something else?
Yeah, you can go to
What's the other way?
If you do the 2 at the bottom, and you do the square root of 2 times everything.
Okay, so what he's saying is perfect square trinomial. The square root of x squared is x. Square root of 4 is 2. And if you multiply those together and double them, you end up with what's in the middle. You have a perfect square trinomial. Excellent. Give it up for Aiden. Okay, so now we want to break this up. Square root of 3 and the square root of x plus 2 squared. Why would I do that again? Anybody see anything that can... Vanessa? Perfect. Excellent. Everybody give it up for Vanessa. She said we can cancel out the squared and square root because they're opposites. So, somebody tell me what you think we're left with as an answer. Alyssa? Square root of 3 And then we also have an x plus 2 left. We canceled out the squared and the square root, but the x plus 2 is still there in existence. Questions? How are we doing on questions? Brandon's hat is tripping me out. He's got one of those little poker hats on. Like the dealers, he's all green today. Would you like to come up and show people your hat? Yay, everybody welcome Brandon. Show everybody this awesome hat that you have. Nice, nice. Oh, Las Vegas. Cool, give him a round of applause. It's like a big flashlight. My eyes just keep going there because it's like glowing green. Okay, last problem. Square root of 3 times the square root of 6 is the square root of what? What's 3 times 6? 18. Can anybody think of two numbers we can multiply together to get 18, one of which is a perfect square? Vanessa. 2 and 9. Everybody give it up for Vanessa. Okay. What is the square root of 9? 3. So it is 3 root 2. The end. Questions? Okay. Let me put let's put all of this up here. Because this is notes for both Algebra 2 and Accelerated, you guys are following the one that says Algebra 2, and then Accelerated when you see this. That is your homework. All right? Everybody go ahead and get going.